Does your mini skid steer have leaky drive motors? Well, mine did, and now I'm going to show you how I fixed them. This is the left-hand hydraulic drive motor off my mini skid steer. I finally finished the rebuild on it. It took me a long time to figure out exactly how to overcome a couple of challenges that I encountered. So now I'm going to rebuild the second motor, and you're going to get to watch, and I will highlight the challenges that I overcame and the tricks that I used to do it. I don't think anyone's rebuilt one of these in this fashion, and so I'm hopeful this helps somebody else get a long life out of their motor. If you just think you have a leaky shaft seal, so in other words, this seal right here is leaking oil on the side of your machine, you really do not need to take the whole motor apart. So I took the whole motor apart in this case just to make sure that there wasn't another problem with the motor, and there really wasn't. It was just the end here, just the area of the shaft seal that needed attention. On the next motor we're going to rebuild here, we are just going to be working on this face right here. So I'm going to set this rebuilt one aside. Let me introduce motor number 2. Okay, so I already cleaned this all up, and I even removed a little bit of rust from the base of the shaft here, just to make my life easier. We're first going to remove all 6 of these bolts. And that's what these bolts look like. They're an M6 bolt that is 20 millimeters long, and they have a hardness of 12.9, so they're extra hard. Okay, so now this faceplate here, you should about be able to get it off by hand, but I find it helpful to use a putty knife or a scraper to just help work it up. I'm going to give this a little tap with a hammer. And you don't want to drive the scraper or putty knife all the way in, just maybe about 1/4 of an inch under the lip. And I'll show you why in a second. Wiggle this up. Okay, very nice. And you do not want to drop any dirt down in this motor once you get this off, so really be mindful of a dusty environment. And this is what the flange looks like once you get it off. So there's an outer seal here, which is a dust seal, and then there's an inner seal, which is a high pressure seal. So these 2 seals here are the main shaft seals that you need to replace. There is a 3rd seal that if you buy a seal kit, you will be replacing, and that's this O-ring right around this flange. So just keep that in mind. If you get a seal kit, it's going to come with other shims and seals and things like that. Really the 3 things that you need are this outer dust seal, this inner high pressure seal, and that O-ring right there. Before we tear this down, I do want to take a closer look at the end of the motor here to show you a couple of things. So if we look more closely at the end of the motor shaft, you can see that there are some bands there, some colored bands. So that is some wear on the shaft. What you see there, the dark band, I believe is just a combination of some soil and also the rubber from the high pressure seal gradually rubbing into the shaft. So that's not ideal. Ideally, you would have a nice, smooth, shiny steel shaft for the new seal to rub against. On the other motor, the left-hand motor that I already rebuilt, this shaft area was heavily pitted. So soil or water had gotten through the dust seal and lived between the 2 seals for a while and heavily pitted the shaft. That meant that the high pressure seal really did not have anything smooth to seal against any longer, and that's why that seal was leaking much worse than this one. This one does not look nearly as bad, but you still have that wear zone on the shaft itself. And if you look at the side profile, you can, I think, even almost see that there is a little bit of an uneven surface there on the side of that shaft where the seals and possibly some contamination had been riding. So this is the main difference um, between my method and I think the most common rebuild method, which is just to replace the seals. So I'm actually going to recondition this shaft surface so that it is a nice, smooth, clean surface for the new seals to seal against. That means after we rebuild this motor, it will have both a new shaft surface and a new seal, or actually new seals, and that should put it in a like new state. So right about now, you're probably wondering how in the world we're going to recondition this shaft surface. Well, we're not going to do any machining, and we're not going to replace this shaft. We're actually going to use a shaft sleeve, which is designed for this exact type of situation where you have a shaft that can no longer seal against a shaft seal due to the shaft being pitted or scratched or damaged or just worn. And this sleeve will allow us to essentially put a new skin on the outer diameter of the shaft. Now, this sleeve is not necessarily designed for this application. It was not spec'd by the motor manufacturer or Vermeer. It is just something that I found that will fit this shaft. Now, whether or not it can handle these pressures and whether or not it can really extend the life of this shaft, that's something that I've yet to see. But it does seem to fit, and so I'm excited to try it. I did have to modify these to make them shorter than originally intended for a shaft, but that is just to fit the the compact package that I have here. So I'm going to include the part number for this and all my other part numbers in the description below, so you can buy this if you want to try this. If you want me to rebuild a motor for you, let me know. I don't know, that might be something that I consider doing. To put this on, you simply press it over the shaft, and it's a pretty light press. It's something you'd like use a mallet to do. But the motor over here, the one that I already rebuilt, the shaft on it was much more pitted than this shaft, and so I used some aviation cement to coat the inside of this sleeve before I pressed it on. That way that aviation cement, which is sort of a thick goo, would actually fill the pits and crevices and scratches in the shaft. And that is actually what's recommended to do with these sleeves when you're pressing it onto a pitted shaft. So this one definitely needed aviation cement. This one, the right-hand motor, does not actually feel too bad. It still has kind of a sandy texture to it. So because of that, I'm still going to put a little bit of aviation cement on this and tap it into place. So this is the aviation cement that I'm going to use, and I'm going to apply just a little bit on the inside of the repair sleeve, but none on the actual shaft. I also wiped off the excess oil from the shaft so that that will not be a problem. I'm actually going to slide this to the side just to make sure that I don't get any inside the motor. So this stuff sort of looks like jelly, like a thin grape jelly, but then it turns into kind of a glue once it sets up. And you get all these hairs with it, so it's super stringy. So you just want to be careful where those strings go. And this is what it looks like after I put that aviation cement inside, and I'm going to now let this set up for a few minutes, and then I will tap it into place. So we're back to the motor, and here is that repair sleeve after the aviation cement has set up a little bit. It's still very gooey, and as you can see, there's a string right there. So this stuff is just kind of nasty to work with, but I'm going to go ahead and slide it down and then carefully seat it over that outer bore. And now we just need to tap it down into place. So to do that, they give you this little tool here, which is meant to tap it on the very end of a shaft, but as you can see, that's not going to work because we have a relatively long shaft sticking out. So instead, I'm going to use basically a piece of pipe. It's this odd looking thing right here. It just so happened to be the right inner diameter to catch that flange. And so I'm just going to slip it down over like so and try to keep it centered. and then I'm going to tap it down into place. I'm going to do a quick check. Yep, and it is going down. Take another quick look. Closer still. Okay, I'm getting really close, and the aviation cement is oozing out the top. So again, I just want to be mindful of that so that I do not let it go down into the motor. I'm going to go ahead and clean up a little bit of my mess here. Again, the priority is don't let the aviation cement go down into the motor. You can see how I coiled up basically 2 long hairs around that paper towel. Okay, I think I have the sleeve pressed down all the way. To get a better look at it, I'm actually going to turn the motor on its side and dump a little bit of the oil out so that I can see the base of the sleeve a little bit better. Yep, I think the sleeve is down all the way, so now I can move on to replacing the seals in the end flange. To make sure that this stays clean, I'm going to wrap it in a clean paper towel and then spray that with some penetrating oil just to make sure that it stays in place. I'm going to start extracting the seals out of this flange. So to do it, it's actually pretty easy. All you have to do is just set the flange down like this. So this is the outside, and then take something that is the correct diameter that's just a little bit smaller than this bore and set it on like that, and then just tap it with a mallet. There we go. So that took both seals out in one fell swoop, and that's just, I think, the easiest way to do it. So this, again, is the high pressure seal. This is really where the magic happens for this hydraulic motor, because this seal is highly unusual. Most shaft seals are designed for low pressure or moderate pressure. This is a high pressure shaft seal. So this is designed to actually operate basically at the full pressure rating of your system. I'll put the number in text down here below, but I think it's somewhere around maybe 1800 psi. So this is a really unusual rotary shaft seal. Because of that, I was not able to source this anywhere other than Danfoss, who makes the motors, or basically China. And I don't know how to steer you there, but I would say if I'm going through the work to rebuild these motors, I would probably default to Danfoss, even though you're going to pay a lot more for this part. I think it's the only way to guarantee that you really get this specialty part, because this is a really special seal. This seal, on the other hand, is nothing special at all. You can actually buy this or a direct replacement at Napa. So I will provide all the part numbers down below. Once you have them out, just go ahead and clean this all up. So this doesn't look too bad on the inside. This, again, looks definitely better than the other one that I rebuilt. But you still have some corrosion on this outer flange, which could keep it from going together all the way. And this face, could use a little bit of cleaning up. And this inner bore, where the dust seal goes, is not really sealed from the elements, so this gets wet. And so this inner bore right here, where the dust seal goes, needs a little bit of cleaning up. There's a little bit of rust. Okay, that feels much better. Go ahead and hit it with a little bit of penetrating oil, and just give it a wipe down. Wipe down those inner surfaces that we already cleaned up. And we'll want to clean this a couple of times to make sure that we don't leave any sand or grit on the inside. And as you're cleaning it, this would be a good time to remove that old O-ring. so that you don't forget to do that later. So I'm going to set this aside in my used parts pile. And now we're going to install the seals. So the first seal we're going to install is the dust seal, and we can technically install it from either side, but I found it easier to install it from the back side. And so the cup, the cup portion of the seal is going to go down, so you're pressing on the solid side of the seal. So you can pretty much push it in by hand from this direction, but it is helpful to have a little bit of help from an assembly tool. So these are pretty easy to bend, and you do not want to do that. So just be careful when you're installing this. And if you tap it too far out, you can just tap it back in a little bit. Just be, again, very careful not to bend it. This is how it should look when you have the dust seal installed. The cup should be facing outward, and it should be flush with the outside of the flange. More importantly, if you feel the inside, you should not feel the dust seal protruding above this surface in here, because the high pressure seal is going to sit on this surface here, and you don't want the dust seal getting in the way. Next, we want to install the high pressure seal. So the cup, the open side of this seal, is going to face up at us as we look at the back of this flange. So it's going to be installed just opposite orientation of the dust seal. So for the high pressure seal, you want to press against this outer ring as you insert it into the bore. Now you need something that is going to press against that outer ring pretty precisely, and so I actually ended up using the old high pressure seal and stacking it on top of the new one, and that acted as a pretty good spacer. I then took this metal ring, which is pretty much exactly the right size, and put it on top of that. So that way I have plenty of protection from damaging the new high pressure seal. I put a bit of penetrating oil on the inner surface there just to make it so it wasn't dry, and take a little bit of hydraulic oil and put it on the outside of the seal. So just set that down in place. Then I'm setting the old seal on top of the new seal, and then taking my metal insert tool and putting it on top of that. When you install these seals, always stop and check and see how it's going. So I can see that I need to apply more force to one side because it's currently going in crooked. I can really feel that the impact from the mallet is like directly going into the workbench, which is a pretty good sign that it has bottomed out. There is the new high pressure seal installed. And of course you can use a hydraulic press for this as well, but these seals don't go in really all that hard, and so that's why I used a mallet. Now I'm going to pre-grease this for assembly into the motor. And what I mean by that is I'm going to put grease on the inside of this seal, the surface that my finger is rubbing here, the same area that the shaft will rub. I'm going to put grease in that groove, essentially, between these two seals. And then I'm going to put a little bit of grease in this O-ring groove around the outside. And this grease is nothing particularly fancy. It's actually just wheel bearing grease because in my mind this is a shaft seal on a hydraulic motor, and that's sort of similar to a wheel bearing on an axle. I don't know, you can debate my logic there, but it seems similar enough that I decided to just use it in this application. You don't want your grease on the inside of the high pressure seal. In other words, you don't want your grease going into the hydraulic motor. So just be mindful about where you spread it. And just like that, we've got some grease inside on that surface. Now I'm going to take some and put it on the outside around that O-ring groove. Now I'll actually take the O-ring, the new O-ring from my seal kit, and put it down into that groove. Then I'll just rub that grease around again to get that O-ring nice and pre-lubricated. Also rubbing some grease on this flange, just in case it can help reduce corrosion in the future. Okay, and then wipe excess grease off. I'm going to pull the motor back over here. There is a little bit of corrosion around this outer edge of the motor, so I'm actually going to very carefully try to clean that up a little bit. And before I can press the new seals onto the shaft repair sleeve, I actually need to do a little bit of sanding and grinding on the edge of it, because you can see the edge is nice and square, which makes sense that it would come out that way, but I actually need to round that edge a little bit just so that the seals cannot catch on that lip as they get installed. Now that I've got several layers of protection to keep any grindings out of the face of the motor, now I'm going to go ahead and use a Dremel tool with a medium-sized drum to just round that edge at the top of the repair sleeve. I finished rounding the edge on the sleeve with the Dremel tool, so it doesn't need to be pretty, it just needs to be rounded so that we don't have a sharp edge for the seals to catch on. But there is actually one more thing that we need to do in order to get the seals installed. And that one more thing is to use something like this as a guide, a tapered guide to let the seals get up over the edge of that repair sleeve. So even though I rounded it, there is still a little bit of a lip there that the seals will catch on. So you have to have something like this in order to help the seals slip over. So I made this out of a piece of aluminum, and now I'm going to just set it down onto the top of the repair sleeve. And if I run my fingers down around it, I can feel that there's no sharp edges that my fingers can catch on. Now I'm going to grab my seal, and with the flange in hand, I'm going to simply set this down over my aluminum guide, and this should simply press on with hand force. If you cannot get it to slip down on, straight down, don't force it. If it wants to cock to one side, that's not good. Don't force that. You want it to slip straight down. If you push and push and push and you can't get it to go, again, that means something's wrong, so don't force it. So let's see here if I can push it straight down over the aluminum sleeve. Oh, I think it went. Boy, it's so close. There we go. Okay. So there's still a little bit of a gap around, just maybe about a 32nd of an inch, and that's due to the O-ring. And I think I'll actually use the screws to pull that down. But now I should be able to remove this sleeve. Yep, so that sleeve came off. Perfect. And we have our new seals installed. So I'm going to get some new screws. I'm going to replace these screws with new screws and tighten them down to a whopping 13 foot-pounds. And I actually do not have a torque wrench that goes that low, so I'm just going to get them basically as tight as I can by hand. And always make sure you use the correct fasteners when replacing hardware. Just going to snug these up. You can see that that O-ring already got seated, so this is pulling down really easily, and I am putting very, very little torque on these. Now I will actually torque these down again to a whopping 13 foot-pounds. I'm going to call that good. So now we've replaced both seals, installed the repair sleeve, and replaced the O-ring around this flange. And that should be all that we need to do to this. So I'll give a close-up here of what the seals look like. But next step is installing this back on the mini skid steer along with the other drive motor. Let me know what you thought of my methods here and whether or not you think the repair sleeve is worth the extra trouble. I feel like it is necessary in order to get a good seal against the shaft, but I don't know. I've never done this before, so this is new territory for me. But let me know what you think of my methods and drop a comment down below. Like the video if it helps you. Maybe subscribe if you want to see more content. And either way, I hope to see you on the next one.